My name is Ryan, and the talk today is TypeScript Beyond the Basics. So a lot of JavaScript developers are probably hearing more and more about TypeScript if you're not using it already. A lot of people have switched over to TypeScript. I'm one of those people. I've sort of said that any new project that I'm going to do, it's going to be TypeScript only. And that's because I've really realized the benefits of TypeScript. You hear a lot of people talk about how it's a bit slow to get going with TypeScript. It takes more time to do things with TypeScript than you would otherwise be able to do with just JavaScript. But the benefits that you get downstream from when you start are just really beyond measure, I think. So I have become a TypeScript fan. I'm totally all in on TypeScript, and that's what I want to talk to you today about, and look at some of the beyond the basics stuff of TypeScript. So a little bit about me. I work at Prisma. I'm a developer advocate there. My Twitter is there at Ryan Chenkie on Twitter, and yeah, I work at Prisma. Do a lot of content, a lot of videos, a lot of talks about TypeScript, like I'm doing today, and about databases, because at Prisma we are all about databases and making it easier for developers to work with all sorts of databases. So right into it. TypeScript, what is it? What do you do with it? Why do you care? If you're not familiar with TypeScript, it solves problems kind of like this. You have a function here. This just takes two numbers. It's supposed to take two numbers and add them together. This is just regular JavaScript. And the problem with JavaScript is you could then go and call this add function and pass in a number and a string or something else, something that completely won't work with this function you've got set up. And the issue here is that you're going to get something that is not valid in your program. So JavaScript suffers from this problem where, like, issues like this, passing arguments of types that you don't intend for your function, is very possible and not a good thing. So TypeScript comes into the picture like this. Very simply, we can say that the two arguments that are going to go to this add function, they are supposed to be numbers. We can type hint them with a colon and say num1 is supposed to be a number, num2 is supposed to be a number. And then when we go to call the function, we can anticipate that we're not going to be able to even run the program if we pass something that is not a number. So in this case, if we pass foo as a second argument, it's going to give us a compilation error, and we're not even going to be able to proceed. So TypeScript helps us in this situation because we solve a lot of problems for ourselves before our programs even run. And that means fewer errors, fewer bugs to track down in the future, which is just great. There is this thing with TypeScript I've been finding, though, and I put out this tweet the other day, which seems to resonate with people, that there's kind of two ways to write TypeScript, or at least it seems like that to me. It's either the first way is JavaScript with just a little pinch of salt, just a little bit of TypeScript, kind of like we've done here, right? Just type in the two arguments, the two parameters, and away we go. But the other way is to do something where you have no idea what you're looking at. And I have found that to be true myself when I look at TypeScript code that looks like this. I pulled this from a gist that my colleague sent me recently, and I'm talking to you today about TypeScript Beyond the Basics, but I couldn't really begin to tell you too much of what's going on here. There's just a lot going on. This is tricky to look at, a little bit tricky to reason about, but this gets into like really advanced stuff that TypeScript can do, and gives you a lot of power to make your programs really type safe, really flexible as well. So this is a super advanced use case. I'm going to talk to you today about some more basic advanced, I guess you could say, use cases. And there are three features that I want to talk about in particular. The first is generics. So we'll talk about generics, what those are, how you use them. And then the second will be index type queries and lookup types. So there's this keyword called key of in TypeScript, and it allows us to do this kind of index type query sort of thing. And then we can couple that with lookup types. We'll see that in a little bit. And then the last thing will be template literal types, which sort of are in the same vein as template literals in JavaScript, and we'll see how those work as well. So without going too much more into slides, that's the last slide I've got. I will jump right into some code to give us a sense of how these things work. So generics. Generics help us to solve this kind of problem. Let's say we had a function, and we'll call it reflect. Reflect is just going to basically return whatever it is that we give to it. So let's say we have an arg, and let's say that we want it to be a number. we will return a number. So all we do is we say, let's return arg. Perfect. So reflect works, right? We can do reflect. We can pass in 1. That's all good. If we want to use reflect, though, on a string, for example, we aren't going to be able to use it as is because we have said reflect always expects a number and it always returns a number. So it's OK in the number case, but in the case of a string, it is a no-go. So that's no good. What do we do here? We could say, well, let's give ourselves 2 functions. Let's have reflect number. So we'll have that as the first function. And then, you know what? Let's copy this over. Let's do reflect string. So this is going to be our second function. Instead of dealing with numbers, we are going to deal with strings. And we can say reflect string here. Oops. And we are good to go with foo. And like we would expect, if we tried to pass a number there, no good. Reflect string only expects strings. So this is okay, especially if we've got just like a couple, types we want to deal with. But if we want to get into more complex types, and especially if we want to get into cases where we'd anticipate any given type to be used in these places for the arguments and for the return, it becomes difficult to follow this pattern. So instead of this, what we can do is we can give ourselves something that is more flexible. And to do that, we will use what are called generics. So generic looks like this. We will go beside the parentheses here to the left side of it, and we'll put in some brackets, and we'll give ourselves a parameter here. So a generics parameter. It's common to see this where you would have t as your parameter. You can call it whatever you want. You could call it type, you could call it foo, you can call it whatever. Common pattern is to use t, so we'll use t. And for the argument now, instead of saying it's a number or a string or anything, we'll say it is of type t. So this seems a little confusing. This seemed confusing to me initially. It's like, what is this t thing? Why is it applied in these different spots? Like, what does this all mean, right? So we'll see how this works. If we, we'll return arg. If we want to use this now for any given types, for example, if we reflect a number, what we can do is say in the generics argument spot, let's make sure that it's going to use a number. So reflect now expects a number in this case. And instead of, if we tried to pass in a string, no good. We are expecting it to be a number. This means that this single function now is much more flexible. So we can pass it a string in this case. And it's good there. Basically, anywhere that we would want to use this for really any type now, this is going to be good. So, for example, we could say pass in a promise. And I don't know, let's see if this will work. New promise, can we do that? If it'll return a promise for us? No, that's not going to work. I'm not sure what we would pass in to actually return ourselves a promise, but in any case, you can start to work with various types. One thing to note here about generics is, given the argument that we pass in, we can actually rely on TypeScript's ability to anticipate what we are sending in. So TypeScript is going to look at what we're sending in, and it's going to apply that type for us automatically. So we don't technically need to pass in here the type that we want to use, but it does become important to do this if we're taking in, say, some kind of input here from upstream, some kind of thing passed down to our function. To protect ourselves all the way through that chain, we should put in the actual type that we're anticipating with our generic. So that's what we'll do there. So there's generics. They get much more complex. You can use multiple generics. You can start to put in multiple spaces here. You can have multiple generic parameters. We'll see a little bit about that as we go, but that's a really quick look at generics. I'd say give them a try. Try to make your code a little bit more flexible that way, and you'll do quite well rather than having to repeat the same argument functions over and over again. Okay, next thing we'll look at index, type query, and lookup types. So let's say we had a type, and we'll deal with animals right now. We'll have a type of animal. We'll have a name, that's going to be a string. We'll have maybe speed, that'll be a number. And let's have size, that'll be a number as well. So we've got this type animal, and now we can use this to strongly type maybe a new animal, right? So my animal. equals name cougar maybe. And what we could do is say the speed. It's going to be like 500. I don't know what this will mean, but speed is 500 and size 30. Whatever these numbers mean, I don't know. We're protected here because if we tried to do something else, we'll be told if we type in this, that is, as an animal, that this property here is no good. We cannot put that property on. It is not anticipated by the type that we've set up. So that's all good. We've got our animal, no problem there. And let's say that we wanted to now use maybe like one of these keys as a string somewhere. So if we wanted to do like animal prop, for example, we wanted to get one of these single props off of here. What we could do is we could say, well, our animal prop could either be name, or it could be speed, or it could be size, right? We could use one of these things to set as the value for this constant of animal prop. So we could set our value here as name. That's okay. But if we tried something that's not in here set as the possible types, then we get a type error. So good. That's fine. We can just, rely on setting our possible string types this way, no problem. But the problem comes in when we start to expand this type, right? So, if we tried to do something else, some other property here like breed, right? That could be a string. If we wanted to then, any data there for now. If we wanted to pick up on this breed, we'd have to go in here and say, okay, well, we've got to add it here now. We've got to add breed as a possible, thing that we could set as our value here. So that's not so great. What we can do instead is use the input type query, index type query rather. And so for that, we can use key of. There's this keyword here called key of, and we could say key of animal. And what this is going to do is it's going to go over our animal type, and it's going to pick out the properties here and give us those as the possible things we can use. So for example, if we do control spacebar, that's a little trick if you're not familiar with it. In VS Code, you can do control spacebar, and you can pull up your list of autocomplete suggestions here. So now in that list, I have got the things that are available here on my animal type. So if I take off breed, for example, and I fix up my object there, it's going to be reflected right away. So key of, that's the index type query. You can use that to your advantage, and it's often coupled with this thing called the lookup type. And so lookup types are kind of like this. If we have like, this is just JavaScript. If we do this array 1, 2, 3 in our array, and then we did console.log array at 1, that's going to give us this value, the string value of 2, right? So that is how we access things in arrays, right? We do this index access kind of thing. We can do something similar like to that in TypeScript, where we are going to have index access to types. And so where this comes into play, one spot that we can see this is if we use it in combination with a generic. So let's give ourselves this function called getProp. And the idea here is that we want to take in a certain type, and we'll do the generic thing right there where we call it T. And we take in the objects that we want to deal with, and then we are going to return, let's just return the object for now that goes in. So this is much like the reflect function that we did above. So we do getProp, and we pass in my animal that is going to, for now, just return that entire object. Let's say, though, that we wanted to have a specific key that we have as an argument here, and maybe we'll just type in that as string, and we can say, give us that object at the key. Let's return that so that we only have a single thing coming back. So the issue here is that TypeScript doesn't work in this fashion where we can type in something as a string and then say, give us the object of that string. The error that we get is like there's this implicit any thing happening because type string can't be used to index type unknown. So there's this unknown type within TypeScript that comes into play in this scenario. And the fix for it is to use the index type query. For that, we can say, let's have another generic parameter here where K, we'll call it K, and we'll say it extends key of T. So this new parameter called k is going to go and it's going to pick up on whatever t is, and then we can apply k to our key here as our second argument. Now this function is happy. It's going to be able to return the object at that key that we pass in. And the beauty of it is, instead of being able to pass anything in here, what we get instead is type safety in this second argument spot. So we can pass, let's see if we get it here, name, size, and speed. We're given the list of options that we can actually use here. So we have type safety kind of two ways within this function. So that is really cool. So yeah, that's kind of combining the index type query and lookup types together, and it can provide you a lot of benefits for sure. The last thing we'll go over, it will be the template literal types, and we'll sort of build on the stuff we were doing just a second ago. And in this scenario, let's maybe look at the case of applying access control to an application. So I have traditionally done a lot of work with authentication and identity. I used to work at Auth0, and I've got courses about security for React applications and that sort of thing. So I've dealt a lot with this kind of thing. And let's have a bit of a contrived example where we've got this access control type. And maybe what we'll have here will be like a list of resources that someone may or may not have access to, right? So posts, that can be a Boolean, so it's like true or false, somebody's got access to it. Invoices, just a bunch of random stuff that you would have in an application. Messages, stuff like this. Pretty contrived for now, but that's okay. So you could, go and apply this access control type wherever you want, and you could then, use it in many different ways. But if you wanted to get the individual things, the individual resources that may be up for grabs, let's say, we could do that key of thing that we just saw. So let's have another type called accessible resources, and that's going to equal key of access control. Cool. So, if we wanted to prove this out, resources, maybe it's like an accessible resources array. And then we could say within here, we've got invoices, messages, and posts. Okay, so we've got all of the properties as like values that we can bring out into this array. So that's fine. So what we might want to do now, though, is we might want to deal with scopes. So like in OAuth 2, we dealt with this a lot at Auth0, where you'd have like a scope where you'd have like read messages, something like that, or create invoices. These are like, if you've got familiarity with OAuth 2, you've probably seen stuff like this. You get like the action and then the resource that you are looking to act on. So scopes are very common in that sense. If we wanted to start to pull out to create scopes as types here, to use these resources along with the various actions you might want to deal with, that would get a little bit cumbersome, right? We'd have to do like, you got your create posts. Let's say this is an array. So we put this in an array. Create posts, you've got read posts, right? All the way down, like all of these methods. So one cool thing that we can do is we can help ourselves out by giving ourselves a type, and let's call it maybe access levels. And we can say access levels would be create, and it could also be read. We could have edit, and we could have delete, something like that. You might call yours something different, but something like this. And then we could have something where we would do a type of scope, and this is where the template literals come in. So if you're familiar with template literals in JavaScript, you can use the backticks, and then you can use $ with your curly braces, and you can put in like a variable there or whatever, something to be executed along with a string. So that's pretty powerful. And as of TypeScript like 4.1, I think it is, it's either 4.1 or 4.2, we have something similar where we can do something like this. We can give ourselves access level and then like a colon, and we'll do another one of these. Accessible resources can be this one. So then if we have a constant of scopes, like say, a constant of scopes that the user would have, that'll be a scope array. we can set ourselves up here and see all of the permutations sort of expanded out. So instead of us going and creating each of these individually, it's just taken these two types together, access levels and accessible resources, and it's expanded everything out for us, which is great because, you know, if we wanted to add another one here and we wanted to add a couple more types, like, I don't know, authors, which is like a string, whatever, and users, string, just dummy types for now, probably would be something different. It'll just automatically expand all of this out. So you've saved yourself a ton of work if you want to have a really strongly typed kind of environment to give yourself hints about, you know, what you have available. So that's the three things I wanted to talk about: generics, index type query and lookup types, and template literal types. You know, all really powerful tools that you can use that are at your disposal now in TypeScript. And I'd say have a go at it. Try to use them to your advantage. And if you're not already using TypeScript, it's really exciting times with TypeScript. I think there's a lot of advantages to using it, and you should definitely check it out. So thanks very much. I'm here on Twitter at Ryan Chenkie, and say hi to me there. Ask any questions you got in the chat, or hit me up on Twitter, and yeah, I'll talk to you there.